This slide will show our study case about Spark processing cluster. The process that we do in each cluster are parsing, consuming, and generating data from JSON to CSV data using Apache Spark. This is the system requirement of the Spark processing cluster: OS CentOS as an operating system, Java as a programming language, Apache Spark as a data processing tool, Apache Kafka as a data distribution tool, and Apache HBASE as data storage. This is the system specification of the Spark processing cluster. The system consists of Spark processing cluster and HBASE or HDFS storage cluster. Spark processing cluster specifications are CentOS 7 operating system, Java 8 programming language, and 10 servers. Each server has 64 GB RAM, 16 core, and 2 TB HDD. HBASE or HDFS storage cluster specifications are 8 servers. Each server has 32 GB, 8 core, 8 TB HDD. This is the general information about CentOS. CentOS is an open-source Linux distribution. The CentOS Linux distribution is a stable, predictable, manageable, and reproducible platform derived from the sources of Red Hat Enterprise Linux. CentOS will be used as operating system of this process. This is the general information about Java. Java is a powerful general-purpose programming language. It is used to develop desktop and mobile applications, big data processing, embedded systems, and so on. According to Oracle, the company that owns Java, Java runs on 3 billion devices worldwide, which makes Java one of the most popular programming languages. Java will be the programming language of Apache Spark that running on this process. What is Spark? We will give a brief explanation about Spark on this section. Apache Spark is an open-source distributed processing system used for big data workloads. It utilizes in-memory caching and optimized query execution for fast queries against data of any size. Simply put, Spark is a fast and general engine for large-scale data processing. Spark will be the main aspect from this process because it does the whole processing. This is the original Spark components. In this case, we are using Spark SQL and Spark Streaming to do the processing cluster. Spark SQL is Apache Spark's module for working with structured data. Spark Streaming allows Spark to process real-time streaming data. Data can be ingested from many sources like Kafka, Flume, and HDFS. Apache Spark architecture is based on two main abstractions. They are Resilient Distributed Datasets (RDD) and Directed Acyclic Graph (DAG). RDDs are collection of data items that are split into partitions and can be stored in memory on workers' nodes of the Spark cluster. DAG is a sequence of computations performed on data, where each node is an RDD partition and edge is a transformation on top of data. Driver program in the Apache Spark architecture calls the main program of an application and creates Spark context. A Spark context consists of all the basic functionalities. Cluster manager does the managing various jobs. Worker nodes execute the task assigned by the cluster manager and return it back to the Spark context. Spark processing cluster is running by executor in each worker at cluster node. This is the overall process of Spark processing cluster. The process starts from HTML that is read by the parser engine. Then the result of the process is JSON, which will enter Kafka to be stored. The data will be read and processed by the consumer engine, and the results are entered into HBASE. Data Generator Engine reads the data from HBASE after receiving input from the user request from Kafka. The results of the process from the Data Generator Engine will be saved to HDFS and will be displayed on the DSG interface according to the user's request. The blue one is parsing process, the orange one is consuming process, and the green one is generator process. All of them are running in the cluster. We will give a brief explanation about parsing process in this section. This is the flow from parsing process. It contains HTML as an input, parser engine to process the input, JSON as a result from the process, and Kafka as the storage of JSON. And after this, the data will be taken by consumer engine. This is the basic information from an HTML. HTML is the standard markup language for creating web pages. HTML will serve as input from the beginning of this process. After crawling, we got this kind of HTML to parse. The red boxes highlight are some parts to be extracted on parsing process. This is the data after parsing process. The result data is in JSON format. This is some function from the code that will be done by parser engine and producing the data to Kafka. This is a flowchart from the code of parser engine. The process will parse HTML to JSON. Starting from input the HTML, then continue to set up all the requirements needed to initiate the configuration step. Next step is to read HTML, mapping data, and parsing data. After that, create directory to save the result. Produce the result to Kafka. Write the result into JSON format. after getting the result, send it to directory. Then the result will be counted and the counter will be inserted to MySQL. Print the counter as the output on the log. This is the general information of JSON. JSON is a lightweight format for storing and transporting data. JSON is often used when data is sent from a server to a web page. JSON will be the output of the parsing process. This is the general information about streaming data. Streaming data is the continuous flow of data generated by various sources. Streaming data is one of the processes that we do. There are three types of data format: structured data, semi-structured data, and unstructured data. Structured data is the data format that we process in this project. This is the general information about Kafka. Kafka will be used as a place for the distribution of streaming data that we process. Apache Kafka architecture has 4 core APIs. They are Producer API, Consumer API, Streams API, and Connector API. This is the example of Zalora data in Kafka that are already parsed. The picture on the left side is the real data in Kafka, and on the right side is the data after we put on JSON Viewer. In this section, we will give a brief explanation about the consuming process. This is the consuming process. It is running after the parsing process. It contains Kafka as temporary storage data streaming. Consumer engine will carry out the process, and HBASE will store the columnar data. This is followed by the dataset generator process. This is some functions from the code that will be consumed data from Kafka and put the data to HBASE. This is a flowchart from the code of Consumer Engine. Starting from input JSON, then continue to set up all the requirements needed to initiate the configuration step. Next step is to read Kafka topic. Consume the topic as JSON format. If the JSON format correct with the site format, then start mapping the data. If not, print data error and stop. After mapping the data, count the result from mapping data and insert the counter to MySQL. The last process is put the data to HBASE table, and the output of this process is a data that's saved in columnar table. This is the general information about HBASE. HBASE will be used as data storage in consuming process. This is the example of Lazada data in HBASE. This is the flow from dataset generator process. Start from a request from user, then the request coming to Kafka to trigger the engine to do the generate data process. The engine send the request to HBASE. Then HBASE give the result from the request to the engine. Then the engine save the data to HBASE and send to interface to show the data. This is the interface for user to input the request to generate data. This is some functions from the code that will be retrieved data from HBASE and send the data to HDFS. This following flowchart explains about the process of data generator. After getting a request from user, the request will be sent to Kafka to queue. The engine will read the request from Kafka's queue and mapping JSON from Kafka. And then it gets the data to HBASE to create file in HDFS and save the log into MySQL. For the crawling process, we use MyDin as case study to be crawled and process the data until we get the HTML file. This is the main display page of MyDin that we are going to crawl as case study. This is the snippet for pusher. It will get category URL from MariaDB and then send it into Beanstalk. This is the data sent by pusher to Beanstalk, which will be used by index crawler. This is the index page, which will be saved by index crawler. This is the snippet for index crawler. It will extract the URL to content page and save the response as HTML. This is the sample HTML from index crawler, which contains URL to content page. This is the data sent by index crawler to Beanstalk, which will be used by content crawler. This is the content page, which will be saved by content crawler. This is the snippet of content crawler. It will save the response as HTML file. This is the general information from a CSV. CSV will be the output of data generator process. This is the general information about HDFS. HDFS will be used as data storage in data generator process. These are some daily commands on HDFS, such as a copy file and show file in directory. The next slide will show a video crawling result example showing the list of HTML files and the example of content inside the HTML. The next slide will show a video of crawling result of MyDin in CSV format. This is the data after we do the whole process. In this example, we use MyDin data in CSV format.